So, first little piece of this next unit, all right? We're talking about correlation, okay? And so, we've been doing a lot of probability. We've been doing a lot of probability statistics and things, and they've been all univariate is what we talked about, just one variable, all right? This unit right here is two variables. So data that consists of measurements of two variables taken from each individual is called bivariate data. So if I ask you for your shoe size and your height, and I want to compare that, all right? The relationship between the two variables is referred to as correlation. The independent variable is the one that you're controlling. That's the x value, all right? The one that is being observed, the one that is changing, is your dependent variable. We're going through this. This is a smaller part of the curriculum, but it's an area that I think could be beneficial for your IA. All right. Some of you may be collecting data and you want to use correlation coefficient to be able to do that. You can run regression. With IB, they only test the linear part of this, but you could run a quadratic regression, exponential, whatever matches your topic. On that topic, when we were in the library last Wednesday, I've got about 30 of the topic outlines, but I'm missing a few. So if you're missing yours, please make sure that you reshare that and get that in. That is a data grade, all right? So make sure you have that. So we're talking about correlation. Now, with correlation, to do that, we kind of want a scatter plot. So a scatter plot or a scatter diagram is helpful in understanding the form. So if we can see all the points, see where they are, then we can kind of determine what's the direction, what's the form, what's the strength. We can do all those things, all right? Correlation is the strength and the direction of the linear relationship, all right? Again, like I said, with IB, they're pretty much only talking about linear. But if you want to on your project or whatever, on your paper, you could talk about quadratic, you could talk about exponential, you can even do more than that if you'd like, all right? But this is an area that I think you can show a lot of work and show some math that if yours falls in here, that would be maybe good, all right? Now, there's a couple different types of correlation. This is probably a lot of repeat for you. I just want to make sure that we go over it so we have it. Positive correlation. As the x value is increasing, as the independence is increasing, the dependent is increasing as well. Positive correlation. What else is positive about that? The slope. All right, so it's positive slope, positive correlation. If it's negative, all right, as the x's are increasing, the y values are decreasing. So it's got a negative correlation. It's got a negative slope there. We're going to talk about line of best fit Thursday and Friday. If I ask you to draw the line that you think describes this data right here, we probably would get 20 different lines in here, because depending on how you see this, there's not much of a correlation here. The points are all scattered. They're all over the place. And so we'd say that that's no correlation. Okay? What I would like to do is I want to go back and I want to refresh on how to put this into the calculator, and then we'll do an example here. All right. So grab your calculator, and I'm going to go new. And where do we go to put stuff like this in our calculator? Not data statistics yet. We're going to go there here in a minute. Lists and spreadsheets, we're going to go first. All right, so we'll go list and spreadsheets and come up here and say that's X, or define it however you want. This is Y. We'll define that. And then you can do it as temperature and people or whatever it is in this case. It doesn't really matter as long as you have it defined as something. All right. And so I'm going to go through here and I'm going to type all these in. Now, typically, I probably wouldn't give you this much data. All right, but it's not a bad idea to have this much data if you're doing this for your IA. The more data, probably the better. It's something that you could talk about in your IA as well. So I'm typing in, doing all my X's first. I'll come back and handle all the Y's. 14 data points there. This is probably going to be the longest part of doing anything in this unit, is getting all the data into the calculator. And this unit's going to be a pretty calculator intensive unit as well. Okay. Give me just a little bit longer. Many of you are pretty close. Okay. So I got that in. The first thing it asked me to do is it asked me to draw a scatter diagram or a scatter plot here. All right. So how can I get the calculator to do this scatter diagram or scatter plot for me? I can go control dot first. All right. Where do I want to go? Now data and statistics. All right. Now I want to go to data and statistics. We've got to assign the variables. So I'm going to say that this is X and that this is Y. And so then I get my scatter plot. Okay? Bless you.
Thank you.
What would we say about this? What would be the descriptor for this scatter plot?
Positive correlation.
It's positive correlation. All right. Now, I'm going to skip a little bit in your notes. All right. We're going to come back and handle a few of these line of best fits and some things in the next couple of days. All right. But I'm skipping probably pretty good ways. I've got this diagram right here. So not only is it positive, but a lot of times they want more than one descriptor on this. So on this one, we can say, okay, it's strong, it's moderate, it's weak. What's the difference between being a strong positive, a moderate positive, a weak positive? How spaced out the points are. All right. So if they're in a pretty tightly packed line, then that's a pretty strong one. I can trust that pretty well. All right. This is getting a little bit more spread out, but I'm still pretty confident where it's going. So it's a little bit more moderate. That would be a weak there. All right. Do you like that idea of being graded or being judged on if you can determine if it's strong, moderate, or positive just by looking at it?
Yes.
Not really. That's kind of a little bit subjective, right? Because we might look at that and I might go, that looks pretty strong on that one, but you're going, no, that's more moderate or whatever. So there's a little bit of play in here, all right, as you can do it. But we want to have that ability to be able to determine what it is, all right? Also in this unit, we want to be able to determine if it's linear or if it's not linear, okay? And so the one that we have right now, all right, we'll look at these things. So if we were to go back and look at the graph that we just did, all right, what would you say about this graph right here? What are moderate, okay? So again, you think strong. We probably wouldn't say it's weak, correct? Is it linear or non-linear? It's definitely linear, all right? Now, one of the other things I think that could be helpful to help me determine if it's strong or if it's moderate is I could take and I could get it to draw the line on there for me, all right? So if I go to my menu, I'm still in data and statistics. If I go to my menu and I say, okay, I want you to go analyze and I want you to go run the regression for me, okay? So if I ask it to go run the regression, I'm going to do y equals mx plus b, which is the top one there. And if I were to do that, then it gives me the line that's going through that data. All right? Now I might use that to determine if I think it's strong or moderate or positive. Any thoughts on that one?
It's okay.
It's pretty good. It's pretty strong. Is it hitting most of the points?
Yeah.
It's hitting most of the points. This one's a little bit off. That one's a little bit off. But for the most part, it looks like it's going through there. I probably would not take off if you told me this was strong or if you told me this was moderate, just based off the picture. Okay? Definitely weak would not be the case. But on this one, if I determine this, I would say this is a probably a strong positive linear correlation. That's what I would say. There's three kind of adjectives there. Strong positive linear correlation. Okay? Now, a lot of times, we don't want to just base it off the picture. we wanna be able to go get a value that tells me if it's, strong or moderate or positive, all right? That value, you probably have heard in the past as the correlation coefficient, all right? That's the R value in our calculator. I know we found it before. All right, we're gonna go find it again here in a second. Now, here's the thing. IB has a little bit different name for it, all right? And don't be disturbed by it and stuff as you're going. It is the Pearson product moment correlation coefficient.
What?
Yes.
That's not British.
All right, it took me a little bit, well, it's named after the person that kind of was
Wait,
working
say
on
it
this.
again.
His name was Pearson. Pearson's product moment correlation coefficient.
Wait, say,
All right?
say it 5 times fast.
Yeah, he wanted to be unique. No.
Pearson's product correlation.
It's in this box. It's back towards the front of your packet, okay? And so Pearson's product moment correlation coefficient, we're gonna talk about how this is kind of devised over this unit, how they get it, all right? But if I have a correlation that is a positive 1, if I have a correlation that is a positive 1, that means it's hitting every single point, and that's in the positive direction. It's a positive correlation. It's hitting every part. It's perfect, all right? It's 100% good, all right? If I have a negative 1 is not also good. It's just in a negative direction. So negative 1 means it's hitting every single point, and it's a perfect match. Obviously, if we have 0, that's in between negative 1 and 1, then that's not very good. The points are all over the place. But we can have this little scale. So on here, you have a couple little scales. It has a scale here. 0.75 and 1 is strong. 0.5 to 0.75. This is a little bit like probability, all right? If you had a probability of 0.75, it's not a bad probability it's gonna happen, all right? I don't know that I would put everything in that,
All in.
all right? But, depending on what you're doing. So there's that. And there's also another scale in here that has it, both the negatives and the positives for you. So it's got all the negatives and it's got all the positives, and it's kind of broken down for you there. Yes,
Why was there like an outlier?
there's an outlier, then that would probably, it's gonna affect my R value, it's gonna affect my correlation coefficient, and it's probably maybe 1 on everything else, but that outlier, depending on how much of an outlier it is, it could drop it either a little bit or drastically.
So it won't be like, it won't ever just like calculate it without the outlier?
No, it's gonna figure that in there as well. If we wanna calculate it without the outlier, we'd have to remove that point from our data set. Okay? All right. Now, here's the thing. We can go find this R value. And so the way that I find this R value is I'm gonna go Control Doc, and I'm just gonna go to my calculator page. So Control Doc, go into my calculator page. Okay? I'm gonna go to the same spot we've been the last couple weeks. We've been dealing with probability statistics. This is more on the statistics nature. So we're going statistics, and we've got stat calculations. We've been there a couple units ago. We've done the 1 variable statistic. In this unit, we're gonna talk about the 2 variable statistic. We'll do that soon. That'll be Thursday or Friday. But for right now, for today, we're talking about linear regression. So we're gonna do number 3, all right? So if I selected number 3, it asks me for an X list. The X list is X. That's where I put those. The Y list is Y, okay? It is gonna store this in F1, so if I wanted to go look at a graph of it later, I could, all right? I'm not gonna do that today. We'll do that Thursday or Friday, all right?
Wait, mine says F3.
Then yours must have something in it already, okay? So you didn't clear your calculator, and there's an F1, there's an F2 already, so it's putting it in the next available,
Okay.
which would be F3, all right? So when I do that, if you notice, if you go back and look, my slope was 6.53. If I go back and look, my slope is 6.53, so that's still the same. My y-intercept is 99.1. Same thing here, 99.1. But the value that I want you to look at is the R value, not the R squared, but the R value, the 0.98. So the 0.98 is my Pearson's product moment correlation coefficient, all right? That's the value we're gonna use to determine if it is positive, moderate, or
Strong.
weak, all right? Excuse me, or
I think it's pretty
strong,
close to 1.
strong. It's pretty close to 1, it's like 98%, all right? So we would say that that would be pretty strong. It is positive, it is a positive value, so it's a positive, strong correlation is what we would say. All right? Good there?
Wait, so what would the R squared be used for?
If you remember from last year when we were talking about residuals,
Yeah.
okay? So this has a little play into some of that as well. So we squared some of those, this and that. So with the linear, you have an R squared, but if you were to do this with any other one, it's only gonna give you the R. And so the R is what we're kinda after, that's what we're looking for, okay? Any questions there? The homework for this is pretty easy, you can work on it right now, you do not have to, it's due on Thursday, it probably ought to take you about 5, maybe 10 minutes at most to do, alright? We're gonna go, at this point in time, I'm gonna answer some questions that you have just in general, or specific questions off of maybe 622, and we'll go from there.